another day of Advent of Code. One day away from being at the halfway point of this year. Excited for that. Yesterday's was a blast. All cylinders firing. Able to knock out that grid math and logic. Very fun. Let's see if today it will be similar. Okay, we got two different inputs. Interesting. Two different sections of inputs. Boom, we got that in there. While we're here, let's run script. Good. Script run. Lots of numbers. Cool ingredients. 3 are fresh. We love fresh ingredients. Big fan. Okay. Ranges are inclusive. 3 to 5 means that all these are fresh. Can't overlap. Great. Okay. Spoiled does not fall under range. Does fall under range. Okay, this seems relatively forward. Give ranges and then tell me which ones are fresh. Do I add up the number of freshes? Nope, I just tell you how many are fresh. Great. So cost fresh ranges. Well, cost AB equals data trim as always, but then split on the double new line. Yep, that is the blank there. And then ranges equals a dot split on the new line, but map each line to, what are we splitting on? We're splitting on hyphens, I bet, right? So L dot splits on the hyphens. Is it always small, large, small, large, small, large? Okay, it is, which means, doesn't mean anything, but it'll help me useful. Then const ingredients, I'm not going to spell that word because spelling is hard, so that's B to the new line, map each to a number. Okay, so now I need to count how many are fresh. There's some coefficient algorithm here. I'm not going to do it right now. So for cost I of ingredients, for cost range of ranges, then I have to check if that ingredient is within that range. Then it is fresh. So that fresh does auto default to false, and it's inclusive. Great. So no, they're by default false. Okay, so if ingredient greater than or equal to range, nope, let's do this. Start and are both inclusive. They are inclusive. Good. Okay, so greater than or equal to start and ingredient less than or equal to end. I think that's how it works. Fresh equals true. Break. Or fresh C plus plus. That's my fresh count. Let fresh C equals 0. Then I return that. Great, I don't know how to count. So which ones are fresh, which ones are not? Well, I don't need to do that. Okay, so which one is fresh? We only have 5 being fresh. So 11 is supposed to be fresh because it falls into the range of 11 to 14. So I need to look at my ranges. I only want to do this once. Slice 0, 1. So let's look at ranges. Ragnas, not ranges. Okay. And then, oh, I have a break right here. Whoops. It was me. Happened too fast. Okay, put the break in there for efficiency. Get rid of that slice now that I've debugged that. Probably have too many console logs. Undefined split. My data didn't get populated. That's not how you get to it. That's how you get to it. Great. What's my script even doing? This is where my computer dies. Okay, so I need to... please run. Okay, so it's running. It's currently eating my computer alive. What I need to do is not do this inefficient range thingy. I assume it's running. Let's get in there. Come on, get in there. Okay, so that's gonna go run off to the races now. Now I need to make this efficient. They've already told me there's gonna be overlaps and there's gonna be samesies and stuff like that. So I need to deduplicate the range looking up logic. I don't have this off the top of my head, so I'm going to go for the lazy way, which is making a giant thing in memory. Cost fresh ingredients equals good old hash map. start end of raw ranges, or let I start I less than or equal to end I plus plus. This is going to blow my memory to smithereens, but that's okay. This doesn't need to be that. This can be a set, actually. There we go. Great. So we've done that. Now I'm just going to check if that can not need to do that. And then fresh is not false. It is either fresh ings has ingredient. Okay, so that works. Oh, I really thought that would have worked. Yeah, so that is working. Now the problem with efficiency of that. Ooh, what's wrong with my split? Set maximum size exceeded. Yeah, I kind of felt like that would happen. I'm concerned what happened with my previous version, so let's keep this. Throw that over there. So I wasn't even able to run the thing as is with the other thing, which was inefficient, but I believe would have made progress. I'm curious about that. Yes, this is what got working. What's my input looking like here? Shut up, Dino. We're not using you right now. Yeah, split, double, double. What's wrong with you? Can I read undefined split? What's A and what's B? Yeah, please stop looking at whatever this is. What's data? Oh, because stupid character turns. I don't like Windows. Oh my gosh, I hate this. Okay, this will work for Windows. Won't work for you. Get out of here. 744. Oh my gosh, I can't believe I lost all that for a Windows thing. Great. How many ingredients are considered to be fresh according to the fresh ingredient idea ranges? Now, the second section of the database is irrelevant. Here are the fresh ingredient ranges. Oh, this is just count all that are fresh. Oh. Okay. Do I just... What do I... Ooh, okay, yeah, this is the efficiency thing. Well, I tried to throw it into one giant set. That didn't work. I mean, I've done this in the past where, like, you eliminate ranges and you combine ranges and stuff like that. I mean, I just need to combine all ranges and then for every range, do the math of the changes between it. So I think it's doable. Just go down to solve 2, I guess. I'm in a really weird state. Get rid of that. Take all this. Yeah, but also I do need the 2 example. Yeah, here's the example. Oh, give me. Okay, boom, that's gonna be fine. I don't care about the A, I just care about the B, or other way around, rather. This one got me flustered. And then I need to forget this off my head. But it's, well, how many ranges do we have? Okay, just congratulations. You're passing that one. That's actually not a lot, honestly. Yeah, we can just loop to loop go double loops on this. So, while false, don't want an infinite loop yet. Let A of ranges, B of ranges, A start, B A end equals A. And then same for B, and then overlapping logic. I do not have memorized, but we will fight for it. What are the possible overlaps? If okay, I need an example. Okay, I think this is an example. Where'd you go? There you went. So 10, 11. Okay, so our ranges are from 12 to 18. That's B. And then A is from 16 to 20. So the logic here is, so it's going to be, so this is angling on the 1/2. So if B end less than A start, combine. I need to think of the inverse. So I have A and B. Let's do A and B the other way. Because I'm going to have to write 4 of these. So if... Oh, I just said the characters again. Okay, and then if A end less than or greater than or equal to B start. Just realized I wrote this one wrong. If the end is greater than or equal to the start. Great, so we have that way working. Now let's shift it to the left. This mapping. If A start less than or equal to B end. And now for the last one, I really should have kept that copy, but I didn't. It's going to be this direction, but over here, if B start less than or equal to A end. Is there duplication here? You betcha. But this will identify that they are the same, and we should pick the smallest of the starts and the largest of the larges. This is where everything's going to hurt my brain. Well, it's already started hurting my brain, unfortunately. Really riding on risk here, but we'll go for it. Constant new start equals math.min a start. Max a end, B end, not before, B end. There we go. So we have the news maximums on my chart down here. It'll be useful someday. What we need to do is we need to replace one of them. Let's delete B and replace A. So ranges, slice. Oh, I should be doing. I need entries. Which one's the number? Because in Python, oh my gosh, it's not telling me. Entries, key value pairs. The keys, the index. Okay, so AI, and then this one is BI. Okay, great. We have that. So we're going to get rid of B. So BI, it was nice knowing you. It always assumes that it's after it. Well, my code assumes it's after it. Now, A is technically just an array, so I can mute that. So it doesn't matter. Okay, so A0 equals new start. Now, this all needs to go inside this loop, of course. And A1 needs to be new end. Great, we've written some code here. So left changes equals false. So change equals true, and if we ever change, we need to break. We need to reevaluate all of our lives. Okay, great, we've done all this. If not change to break, this gets us out of the while loop. Then we will look at ranges, see if we've actually done something with our life. Here comes the infinite loop. Dun dun dun. Okay, well, I knew it happened. Didn't expect it to happen that quick, so let's put a break on that. Hey, this is the part. Okay, put a break down there. Okay, computer. Good computer. Oh, I'm running on the real one. That's foolish of me. Need to run on the fake one. Oh, what's the fake one? 14. Okay, let's get 14 working. So yeah, it's not 14. We failed there. But let's see. So yeah, this could have been working the entire time. Just inefficient computer. Being inefficient. Oh, nope, and nope, and if infinite looping, cool. So this is never happening. So I just need to look at things. Looking at A and looking at B. They're the same one. Cool. Why are you never looking at anything else? Well, firstly, you're comparing to yourself, so that's always going to fail. I shouldn't be doing that. I definitely am spinning here because I should have figured this out earlier. Nope, another infinite loop. Okay, great. So we have A, we have B. They're not an overlap. I'll chuck that down here. They are considered changed though, which is awkward because it shouldn't be possible. So one of these. Great, so B end is greater than equal than A start. Well, yeah. Dang it. Okay. Time to bring back the graph. I wrote this expression terribly. Okay. I need to write these correctly. Only 4 iterations here. I don't know how I messed it up. So let's go back from scratch. So we have it where they're that way, and then we have it where they're that way. And then we have the inverted where it's the same way, but it's A and B the other way around. I am definitely not winning any speed prizes here. Okay, so let's break this down. If the B end is greater than or equal to the A start. But when it's 3 and 5, I'm not understanding. Yeah, like these aren't physically overlapping, so if I were to represent these ones, new graph. So we have A start, A end, B start, E end. B end greater than A start. Yeah, that happened. Dang it. So they need to check if one of these is within the range of the other two. Okay, so if A start is greater than or equal to B start and A start less than or equal to B end, then it counts. Is that the strategy? Each one of these needs to look at the other two to see if they're within. Okay, I can fight that. If A start greater than or equal to B start and A start less than or equal to B end. Okay, that's one down. So I'm going to write something here just so things don't explode. Let's go for the next one. A end greater than or equal to B start and A end less than or equal to B end. It's 2 down. What's happened here? There we go. It's technically an or, not an and, between these ones. This is where AI is actually really good, but I'm here. B start greater than or equal to A start, and B start less than or equal to A end. Final one, and I'm losing my graph. B end. Oh, get back in here. the end greater than or equal to a start, and b end less than or equal to a end. Okay, let's see if I've cobbled together that. Well, dang it, another infinite loop. Okay. Okay. Well, let's see which ones are considered changed. Okay, the one at the very end. Well, that really doesn't tell me a lot. If changed A, B. Okay, yeah, these are ones I expect to be changed. Hey, that's not a range I originally had. What'd you do? Oh, well, yeah. Well, that's before and after. So let's look at before and after before you go butchering my stuff. 10 to 14, 12 to 18, 10 to 18. That's right. And we got rid of. Hey, be nice if when you delete the thing, you actually deleted it. Crazy. Okay, great. So we've eliminated all the duplicate ranges. Now we just go do math. I'll keep this chart around. It's been very useful. Please scroll. Now this isn't going to be too efficient because it finds matchings one by one, but nobody cares. Okay, now we just need to go through all the ranges and do the math. So for const start end of ranges, let total equals 0, well, plus equal end minus start. Probably off by 1. 12 not equal to 14. Plus 1. Great. How much is this going to eat my computer? Man. Oh, it's no. I love working on a Windows machine. It's the best thing in my life. Hey, okay. It took a little longer than I would have liked for me to actually figure the logic out. I won't say that. It didn't take me that long to figure it out. I just needed to visualize it appropriately and walk through it. I simply just haven't done this in a long time, and I just didn't have the top of memory. The muscle memory was gone. But I was actually broke it down pretty well, so I am happy with that. Well, that is a solution. Let's jump back into it and see officially what do they want from us. So let's see. Oh, well, Chrome's complaining about something. Be quiet, Chrome. Okay. Now, what did they give us? So they gave us two inputs, a range of IDs of things that are considered fresh. Now, these seem to be from smallest to largest. That's really coincidental. What does matter is that the first digit or the first number is always smaller than the ending number, so it messes up there. And the trick that they kind of hinted at is that these ranges can overlap. That's important in part 2. They're also inclusive, which means 3 to 5 is 3, 4, and 5, not just 4, not 3, 4, or not 4, 5. So you got these ranges, and then you got a bunch of ingredients you'd like to evaluate. And you're meant to tell or count how many of them are fresh. A fresh ingredient falls into one of the ranges provided, or the cumulative valid ranges. So 1 is not fresh, because it's not in any of the ranges. 5 is, because it's in these ranges. 8, 11, 17, all that good stuff. Which means you get 3 fresh ingredients. And I actually think this is easily and great to visualize. So we're going to go visualize it. Oh my gosh, it's on fire. Please start working again. What's wrong with you? Why is that on fire? Okay, well, that was already on screen. Let me see. Oh, okay. Well, I know why that's happening. Let me pause one moment to go fix that up. See if I have any. Okay, I have bought in us time. We have time. I ran out of space on my C drive, which is hilarious. Thanks, OBS. Eating all my drive. We back. So back to our TL draw. Let's visualize this here. So we got these ranges, and I'm actually gonna draw it out. Wow, my brain's like, why would I want to do this? Doesn't matter. Oh my gosh. I should have written code to do this. Okay, so we have all these numbers. Let's mono them. And these are the ranges we have. So if we're to draw them out, we have one range, which is 3 to 5. So, boop, it's like that. Technically, it's like that. Well, actually, it's like these. Ooh and ah. There we go. That's one range. What's the next range we got? We got 10 to 14. Boom. What's the next one? 16 to 20. Oh my gosh, I failed on spacing. Please, I need to fix this. There we go. And the last range we have is 12 to 18. So I'm going to move this one up a little bit to see the idea. And now the actual ingredients. What are the ingredients we have? 1, 5. Let me drag them in here. That's not what I put in my clipboard. Oh no, it was. I just didn't see it. So we have 1, 5, 8, 11, 17, 32. We do have 32. Great. Way over there. So when you draw it out like this, obviously we can just visually see 1 is not in a range. So invalid. We're not fresh, but 5 is. So we got 1. 8's not overlapped. 11 is. And then 17 is. So 1, 2, 3, 1, 2, 3. That is what part 1 is asking us to do. Now, part 2, this is where it gets a little more challenging, is saying that anything, like the ranges themselves, are what is fresh. So it's basically saying to imagine a world in which you have ingredients on every single number in the universe, but only the ranges are still valid. So how many fresh ingredients do you have? Now, the trick here is that if you don't collapse the ranges, you get duplicates. So if you were to just like add up all of the ranges, you'd be like, well, this one's 3. And then you come over here and be like 1, 2, 3, 4, 5. This one's 5. I'm actually going to do this elsewhere because this is, we're talking about part 2 now. There we go. Part 2 is over here. No. 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 Yes. So if you were to manually count the size of these ranges, you'd be like doing that. Like, great, I got a 3, I got a 5, I got 12 to 18. So 1, 2, 3, 4, 5, 6, 7. And then you'd be like, and over here I got 16 to 20. 16, and I got 5. But that's not actually how it worked, because you have 3, but then these ones overlap. So instead of 5, 7, and 5, you have 10 to 20. You have 10, not 5 plus 5 plus 7. Now, the brute force way I had initially tried it was I'll just create a set of every single possible valid ID in the world. And that would work because you would add 12 and then you would add 12 again and it would deduplicate. Fortunately, sets got a set limit of size. You can't, they're not infinitely sized. Same for any data structure, so that wouldn't have worked. So, what they're asking really in part 2, and this is kind of already bled into the how by accident, is for you to collapse these ranges. And I will talk about that when I talk about how I did part 2. Let's stick with part 1. So, I already deleted some code here. Let me bring this back. It's not 14. Well, it's not solve 2. Solve 1, and then, yeah, we hate this thing. Oh, where's the rest of my input? There we go. Kind of important. Boom. And yes, it hates this because there are no carriage returns here. Can I just shove some in? Yeah, I figured that. Actually, that would work. There we go. Ignore my windows making us all have not fun. I'll also commit this too while I'm here. Wow, there we go. Okay, back to understanding how this works. So first what we do is we have 2 different inputs embedded in this one input. I can see that they're separated by a blank new line. So I split them by splitting on 2 new lines. Because I'm on Windows, it has to be a carriage return followed by a new line, but this results in us having A and B, which are perfect names for this. So it's all the chunks, it's all the ranges, followed by all the ingredients. Then, for all the ranges, I split them into their individual lines, which looks like this. So you have a bunch of strings where it's number hyphen number. And then for each of those, I split them by their hyphens. So that looks like, my mouse. It's not my mouse, it's my hand. So that makes each of them turn into an array of the first number followed by the second number. Then I pass that to map number, which converts those strings of numbers to actual numbers, like so. So it's an array of arrays, but each of these inner arrays is too long. The first one being the from, or the start. The second one being the to, or the end. For ingredients, it's a little bit simpler. It's just an array of strings convert to an array of numbers. Now I do the ugly and the bad thing that was good enough to work. I go through every ingredient, and then for every ingredient, I go through every range. So technically this is, what is it? Well, it's been a while since I've actually done this. Big O of complexity of ingredient count to the power of range count. Something like that. It's not good, but it's good enough. So we go through this and we look at every start and every end, and we see, hey, is this ingredient within the range of the particular range I'm looking at? If so, I'm going to call this ingredient fresh, and I'm going to break to be a little bit more efficient. Don't need to run anymore. And if this one is fresh, I'm going to add to the count of how many are fresh, and then return that count. Relatively straightforward. Part 2 is the one that things get a little crazy in. So, the work here is to deduplicate and merge these different ranges. This is actually a relatively, I'd say, popular problem. It's not unique at all. You see this a lot of scheduling programs and stuff like that. Even probably a couple leak codes about it. Now, the strategy, and I'm going to make another copy of this, because this is actually a good example, that you just want to merge them together. Now, the way I did it wasn't too efficient. I was just picking 2, almost at random, though they were in sequence, ranges, and I was asking, do they overlap? So, let's say I picked this one, and then I picked this one. Do they overlap? We can see with our eyes the answer is no, so let's actually move on to a more entertaining one. These 2. Checking if these overlap. Now the answer we can see with our eyes, yes. So what we would do is once we detect the overlap, we transform it from, I need more real estate. Transform it from them to being two separate ranges to being a single range. And I chose keeping the original A range. So for visualization purposes, it goes up. Then it extended to where the other one ended. Ta-da! Then once I've done a single merging of any two ranges, I restart. I go back and recompare all of them again. Yes, this is a waste of efficiency. There are more efficient ways of doing this, of keeping a track of the ones that are constantly overlapping and keep merging them one by one. I didn't do that. Wasn't that fancy. So it would come through again. It'd see these two are overlapping using all that detection. It would then make this one's minimum and maximum be this one's minimum and maximum. So increasing the width of this and dropping that. The final piece of the actual problem is just summing up the sizes of the ranges. So this one's 3, right? So yeah, 3. Then this one over here, this one's 10. And that gives you 13, which is the answer. Well, it's 14. Okay, it's technically 11. I swear I know how to count. Because it's inclusive. That's the what this is doing. The how, as you saw, I kind of had to slow myself down and walk through writing the overlapping logic. Now you can, this is, for the purposes of this one, this is the conditionals to determine if any of these two overlap. So I had to write it out and determine, are you in the here? Are you in here? Are you in here? Are you in here? Is there a more efficient way? 100%. Do I know it? I do not. This is also, I also call this a subset of collision logic, because technically, from a mathematical perspective, these are just two polygons. Now, we're in a one-dimensional world, or two-dimensional. We're not in a three-dimensional world, but this is just collision logic. Do these two collide? So, like, could have been better ways of doing this. I don't have them memorized. I don't have them off the top of my head, but I knew what I wanted to do. So after slowing myself down and walking through it, was able to express it as code and come up with this beautiful bounds checking doohickey. Yeah, I'm not sure much of this needs additional walkthrough. Entries got me the index and the value. I needed the index so that way I never compared it to itself, which wasn't truly necessary, but I really needed the index so I could splice and remove whichever one B was, which I also didn't technically need. I could have done some index ofs, but I didn't want to risk it. But yeah, once I found there were an override, I figured out the new minimum, the new maximum of the start and the end, got rid of B, updated A, said things have changed, exited all the loops, and then counted up the total sizes of all the ranges, plus 1 to be inclusive, and that was it. Time to make it refactored. So I think honestly the only difference here is, so it's going to be a single function that returns both the ingredients and the mains, and you just pick which number you return. So we're going to use the efficient version over here. Call you solve, and let's go ahead and include B in the equation. We have the ranges, we have all of that. Select range total. Well, I could have just renamed it there. range total, there we go. And then I'm going to copy the fresh ingredient logic right here, because this is still, I won't say this is the most efficient, but this isn't inefficient. Fresh ingredient count, there we go. Did I not bring that variable? Nope, it didn't make it. Let's bring it back on over. There we go. Now this is a lot quicker because we're not looking at ranges that could potentially overlap. So this is as efficient as one would expect to see it. Again, there's probably some efficiencies to be gained here. I don't know it, and I don't need to know it. So from here, we're going to return both of these. Range total, fresh ingredient count. Now we got to call this thing. So this one, we care about the fresh ingredient count. Return solve data. Fresh. It'd be useful if I got some autocomplete here. What's the point of TypeScript? I have a .any. Should get rid of that. It was me. TypeScript was not wrong. I was wrong. And range total, and both of those. Oh, because there's no R thing here. Well, that's okay. I will resolve that shortly. Yeah, so I guess we're gonna need to call this parts. Ooh, is there a way I can do that is ooh, it works. It's a little janky there. You don't see that in too good quality code. Okay, let's give these some good names. Whoa, that didn't do anything. There we go. Raw ranges. Raw ingredients. Okay, we're getting a little cleaner. Let's see if we actually want to lift this around. Oh, hold on. Oh, what did I just click? Don't require ingredients from some random library. Okay, I'm going to see if I can optimize. Well, first of these can be just straight up consts. They're not changing. Secondly, I'm going to see if I can drop the index checks. I believe I can by simply using index of for the B index, and I can just do triple equality for if they're the same. So boom, that should influence that. And this is ranges index of B. Like a charm. Makes that a little cleaner. Awesome. Now, yeah, there's some cleanliness to be done here. Let's not go there yet. Cleanliness to be done here. Let's rename this. Ingredient. There we go. I'm gonna do all my parsing up here. I don't like it being down there. I don't like these three lines in general. Yeah, I don't like them so much. What do we call this? What do y'all call this stuff? Parse database. Return ranges and ingredients. There we go. Spell the word ingredients one more time. After passing in the data, and it works like a charm. My types are a little too loose. Let's knock that out. Okay, now those are consistent, and that is cleaner. Let's give it a format. Do I need this anymore? Nope, actually ended up not using a set, because that wouldn't have worked anyway. Okay. Let's see where else we get a little more friendly here. So now we're down to 3 sections. We got the collapsing of the ranges, the totaling of the ranges, and the counting of the fresh ingredients. I feel like this can go elsewhere. Combine ranges. That's a good name for it. You go down here. Tempting to throw this in a parse database. We're going to get this made first. Well, this is an array of numbers. It's not really, though. It's an array of number tuples. So that's more accurate. There we go. Ooh, the trick about this, technically this is mutating the original thing. So I don't need to return anything. But I will, so that way it's nice and chainable. So I can do something like this. Oh, do you think you're a number? Well, you don't know. Okay, let's cast you a bit to what you truly are. Then that works, and then this doesn't need to exist. Awesome. Please, just the totaling logic in here. It's too magical. So now, you got the parsing in one function. The combining of ranges are right there. Nice and readable from the top down. I like that better. Totaling of ranges. I don't think these 4 lines get much simpler. I can get fancy with the reduce, honestly. Let's see how we like that. Oof. Oh, that's an interesting expression. Let's put it over there. Start at 0 for safety. I think I might have done this wrong. Let's see. That's where the accumulator goes. Oh no. Got things swapped around. Come on. There we go. Yep. So got that nice and simplified a little bit more. Ooh, so the readability just suffered a bit though. I'm not willing to sacrifice the readability for that fancy. We will look at our 4 lines and we will love it. If we can read it. Awesome. Let's see what we can do to fresh ingredient count. So this goes through, finds if any are fresh. Whenever you're making a Boolean, flipping it and then instantly exiting, you are just asking to use the sum method or one of the array helper methods to early terminate. I think we're looking for sum. So let's see, this is ranges sum. Oh my gosh, when did Copilot turn on? Please go away, Copilot. You're spoiling me. And that's not the symbols. Now, thankfully, it's this logic right here. So yoink, 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 yoink. Awesome. So now it says if any of the ranges, if the ingredient of this statement is true, which is what we were saying before, it will early terminate just like I was manually doing, and then it'll count accordingly. Now the trick is that this can actually be made a little more readable. So we're saying ingredient greater than or equal to start and ingredient less than or equal to end. I personally like the visual appearance of inverting this like this. So it looks like it's start, ingredient in the middle, end. Now in Python, this is actually a feature. You can do like A less than or equal to B less than or equal to C. This is the Python feature I'm effectively visually representing in JavaScript. This is all we got. It's close enough. And now I can take that. It's a variable only used once. Chuck it straight in there. And I can go even further. And since this is a run incrementer over this, I can do a reduce over this. Well, I can do a filter or a reduce. Or there's like 3 different ways I can do this. I will do a reduce is less readable to most people, so I'll actually go for the filter. So I'll take the ingredient and I'll be like, hey, if this ingredient is fresh, then I keep it. I didn't mean to cut that. And then just .length it to get the fresh ingredient count. Boom. Same number. Works all the same. We did lose some readability though. Well, we lost some readability when we did the sum also, but I think that one is still inferable. You can just use your eyes and be like, oh, we increment the number of fresh ingredients when something is fresh. Well, this must tell us if something is fresh, right? Don't need every line commented and explained. I think this is a nice balance between cool and readable. Now, the last thing I want to do here is, well, A and B aren't honestly the best of names, but when you're arbitrarily comparing two things, A and B are fine in my book. A start A and B start B and do we need? Yeah, we need the full value so we can do this check to not compare against itself. Checking if the overlaps that needs to happen. New start, new end. Those can be end-lined. The deletion of the old one. Yeah, it's not really a place it needs to happen. Now this break can go straight into here. Makes life a little easier. Now these ones unfortunately do need to live. Like this one needs to happen or else it'll keep looking through other B's even though I'm doing the break to try and be efficient. Usually you do this to make sure you don't reprocess or double process thing when you're deleting something from the thing you're iterating over. I don't think it's going to hurt though. It might run a little bit more, but I don't think it hurts. And it does not hurt, it still works. Doing our exit, of course. Now, if we have this pattern here, we might be able to make a do while. So what is a while changed? There you go. Let's see if we can do while this instead. The weirdest pattern I've chosen to implement in it. I need to bring that up here and then change back to false. There you go. Huh. I don't really like that. We just abuse a for loop. Changed equals false. Changed. Not changed. Yeah, we can do a for loop. Just abuse our 3 statements, get our lives going. Oh, that's just infinite loop does. Okay, what if we just no op here, which is what was that? There. Yeah. Doing cursed stuff here. Why do you need an expression? I know why. You're being annoying, JavaScript. So let me put nothing here. Oh, you are letting me put nothing here. Are you? Come on, cursor. Okay, yeah. Okay, I don't. My Quaco was just having a moment, I guess, or I was having a moment. So this set's changed to false. It says continue as long as nothing has changed, and then flip across. Okay, we need to improve the name of this. Not format document. Merged, arranged. Ranges merged. Okay, so we're going to say there are no ranges merged, and you'll continue as long as another readability hit we took with this. So it's supposed to be a let. Get rid of this infinite loop. The variable's at the top, it's at the bottom, it's a while loop, but this is more readable. So it lives. Trying to think if we break this into another function, we could simplify it a little bit, but I don't believe there was enough value to do that. So I won't do that. Okay, we have that function, the main function, our two main entries hitting our main. Yeah, this is it in my mind. I'm trying to see if I introduce any new code that needs explaining. Aside from the sum, which I already walked through. No, no new complex code. So with that, we'll commit and we will call this a solve. Okay, that was a blast. Looking forward to seeing what we get for tomorrow, the official halfway point of these new 12 days of Advent of Code. I'll see you then. Bye-bye.